All right, so let's see. So class. No, you guys say it like I said. So I go class, and you guys say yes. I say class, class. Thank you, appreciate it. At least try and play along. Otherwise, it gets completely boring. I just try and tell jokes just for myself, and no one actually is paying attention. So anyway, area between graphs. Now, some of these things are actually pretty easy. Now, if you notice right here, we have two graphs. So we have a y equals f of x, which is the blue line, and y equals g of x, which is my red line, or pink line in this case right here. And we're finding the area in between the two graphs. Now, what happens is when you're finding the integral, you're actually finding the area under the curve. So the blue line goes all the way down to the x-axis here. The red line also goes down to the x-axis here. Perfect. Yes, that's it. So, since everything is down here, we do, to get just this, it would be the integration of this minus the integration of this over the same course from A to B. Does that make sense? Yeah. Okay, good. There we go. Okay. Here's the math, the way that you could look at it. This is actually puts it into one function, but I don't like always doing it in one function. I like separating it. Okay, because quite often you're gonna actually have to separate it into parts anyway. Anyway, but it would work out. So same thing you would actually do from integration from A to B of f of x dx minus integration of A to B of g of x dx. So both ways work. Find the area A of the region enclosed by the graphs e to the x and x to the 1/2 and lines x equals 0 and x equals 1. So setting up your integral, if you actually did this correctly and you saw it on the test, this is one of the ones that just writing it out correctly was going to give you the whole point. So what would my integral be? How do I know it's like that? This is the key. How do you know which one's on top? It's always top minus bottom. Which one's which? You don't know? Okay, do we know a couple values? Okay, so let's start like this. What's e to the 0? Okay, so it'd be 1. What is x to the 1/2 to the 0 power? X, which is 0, right? To the 1/2, right? That would be 0, right? So just by checking my points in my function, I can actually tell which one's going to be on top, which one's going to be on bottom. So starting out right here, this one is, because this one would give me 1, and this one gives me 0, this one's top, this one's bottom. If they change, then we'll actually see that also. So that's actually going to get into later on type topics where they will change, and I have to change the balance on that. And I'll actually change my integral. All right, so what is the integration of e to the x? E to the x from 0 to 1 minus x to the 1/2 is going to give me x raised to the times, and that's from 0 to 1. So this is going to give me top minus bottom, so it's e to the first minus e to the 0, which is 1, minus this side over here, which is going to be top minus bottom, which is going to be 2/3 minus 0. Minus what? 5/3. 5/3. So it's e to the first minus 5/3. Now we're going to pull up our handy dandy calculator, which I know you guys all have your handy dandy calculator with you, because I keep telling people use the calculator because you're not going to know how to use it come test day. So Swiper, one of the other ones. Make sure you put it all the way down. Okay. Is the light going? Yeah. It's going there. Because it's completely dead. It's fine. Completely dead, so it's not gonna. Alright. So I'm gonna go to my graph. So my function was e to the x, enter. And my next function, I hit tab, was x to the 1/2. What are my bounds? 0 to 1. So I'm going to go to my, I'm going to look at my window, and I'm going to go from 0 to 1. So there you go. Clearly, e to the x is on top here, right? All right, so let's see how we do this one here. So I'm going to go menu. Did you grab the notes? Okay, menu. I'm going to analyze, and I'm analyzing bounded area, lower bound, 0, upper bound, 1. So my answer is, there you go. It's not doing what?
I'm on the lower bound part. I've got 0.
No, just hit the number 0 and hit enter, and it goes upper bound. Because you could use the mouse to actually drag it over too, but it's easier because it's hard to actually get it at the right spot. Just put the number 1. There you go. Yeah. Will my calculator do everything for me? It does everything, and I keep trying to encourage you guys to use the calculator as often as possible, but you got to get used to this. So, let's see. Let's see. E to the first minus 5/3. On a test, you'll mostly have to have this answer as your correct answer. E to the first minus 5/3. Could you approximate your answer and then check your answer? You can put in the calculator, get an approximation here, and then you can actually check your answer against what the calculator says. But the only problem with this is you have to distinctly understand the calculator. You got to make sure you put everything in correctly. Otherwise, yeah, you're going to be off. Thank you. All right, so here's the graph of what it really looks like. But we ended up graphing it ourselves because we're just that much better. Find the area A of the region enclosed by the graphs of these two here. All right, now I got to figure out where are these two equal. Because if it's enclosed, that word enclosed means that there is places in which that they're equal. I am not given bounds. These two lines will cross each other. So I'm going to go.
What happens if it's under the x-axis?
Give me 1 second.
Because it would be though.
If it's under the x-axis, then guess what? It's under the x-axis.
What if it's negative or positive?
Yeah. If it's below the graph, it goes from, if it's negative, it takes the area from that negative and goes up to the x-axis, and that's your area that you have. From under the graph towards the x-axis. And it's above, if it's above, it's from that function down to the x-axis.
Well, because this one is gonna do that and it's gonna cross, but
Okay, let's do the math first. So let's start by setting it equal to 0. So I'm moving everything to the right. So I'm going to say 0 equals x squared minus 10x plus 3x minus 8. So that's x squared minus 7x minus 8 equals 0. So that's going to give me 0 equals positive 1. There you go. So that means that this is going to be bound there. So I'm going to have my integral set up from negative 1 to positive 8.
and could you put it into the integral as the whole like x squared minus 7x minus 8?
No, because that would give you one line. I need 2 lines. I need top minus bottom.
Could you do in the 10x minus x squared plus 3x minus 8?
I don't know yet. I think you're trying to jump too far because I'm about ready to say what we have to do next. If you remember from the last question, what did I ask right when we started it? Which one's on top? That's where I go from. Which one's on top? I know that they're both equal to each other at negative 1. So let's try at 0. Because that means that they cross only at these 2 points here. So to see which one's on top, just pick another number. I love 0 because 0 is one of those numbers that, cancels out and gives me a lot of easier math. Plug in 0 to this one right here. Okay, plug in 0 to this one here, I get. Which one is greater, 0 or -8? 0, so that means that this is top. That's all I had to do. I just had to check one of those numbers to tell me which is going to be top and bottom. So I'm going to do my top, which is going to be my 10x minus x squared dx minus bottom of 3x minus 8 . Alright, I'm going to go move to a new page to actually do the math on this one. Yeah.
If you switch the -1 and an 8, will it still be the same? Because
What happens when I go from negative, when I change the balance?
It'll be a negative, but when you
Are you saying on the second part, change it instead of minus?
no. We'll go back up like a little, like to the first part.
What, x minus 1 and then x plus 8?
Yeah, it just basically a little above that at the start. I put 3x. I did -3x instead of when you.
Oh, you moved everything over.
Yeah.
You moved it the other way. Okay, so that means you're starting off with a negative x squared plus 10x minus 3x plus 8 equals 0.
Yeah.
Yeah.
You can, but what's the problem with this one right here? My leading factor is negative. I can't have that in this. Because two negatives will not give me a negative.
Yeah.
So that's why I move it so I can have a positive leading coefficient here. When I factor, I want to try and do that. Otherwise, after I do this, I have to multiply everything by -1 anyway to change the signs, which eventually just comes back to what I have over here.
Oh, okay.
All right, so for those people not playing on their phone, they're actually paying attention or using a calculator. Let's see. So integration from -1, 8, 10x minus x squared dx. So let's do that. All right, so right here, let's see, that's going to be 10x squared over 2 minus x cubed over 3 from -1 to 8 minus bracket 3x squared over 2 plus 8x from -1 to 8. Please tell me I copied this down correctly too, so. No, it's -8, sorry. There you go. All right, and actually integrating here. So let me see, do a little math. So it's gonna be 5x squared, 64 times 5. 640 divided by 2 instead. That'd be even easier. 64, so 640, so that's 320.
Yeah.
Minus 8 to the 3rd power. So like 216 or something like that. Or no, 192. You guys got calculators. Come on now.
322.
What is it?
422.
422?
8. Oh, 512.
512?
Yeah.
Wow, I was way off. And did you divide it by 3?
By 3.
It doesn't work out.
56.89.
Okay,
889.
there you go. I'll do that. Minus the lower bound, which is going to give me 5. And negative, so that's plus 1/3. Yes. Hopefully. -1 to third power is -1. Change that to a plus, right? Okay. Minus bracket, all this over here. What's it going to be? 64 by 2 is 32. 32 times 3, 96. Minus 64. Minus the lower bound, which is going to be 1, which is 3 over 2, plus 8. So let me see, this is going to be 315 minus 513 over 3. 513 over 3 is going to be 171 minus 32. And that's going to give me a over 2, so 16 over 2 is 19 over 2, so negative 19 over 2 plus, there you go. And as we put all those together,
Why do 315 minus
I combine this one. So this and this, so 320 and -5, 315. This right here, if I add 1/3, that'll give me 513, and 513 divides by 3 evenly into 171. And then that one's 32, and the last one's 19 over 3, or 19 over 2. You can put it all in the calculator, see what you get. That's 203. 203. That's 112.
Yeah, I got that.
You got 243?
121.45.
Oh, wow. I was struggling on that one. Yep. Okay. Woo. Alright. And here's a graph of what the example is going to look like. So if we were to graph these, we could see our two functions are going to intersect here, and they are going to intersect here, which we have our coordinates of those. And if we were to graph them first, we could clearly see which one is going to be on top and which one is going to be on bottom. So that's important for these. You got to figure out which one's top wheel and which one's bottom.
What happens to negative closure?
What do you mean?
So would this be the total area or the net area?
This total. This is all this shaded.
How? Because normally it's just the net area.
Okay, let's look at the blue by itself. Blue. All that right there is negative, right? So just the blue itself. Right. I went too far. Yes? Okay. Minus the bottom. The bottom. Are you okay with that part right there?
Yeah.
Okay.
And then would that extra piece have been added in?
Yep.
So that would have to have been added.
Yes, because you are subtracting a negative.
Okay.
Make sense? Okay. All right, so I'm going to leave you off right there. I'm going to pick up the rest of this tomorrow. Make sure everyone likes, shares, and subscribes. Hit that notification button. Buy stuff from my merch store. I got new shirts on the merch store.